Hi, and welcome to the fourth grade science curriculum preview for the fourth 6 weeks. Today we're going to talk about Unit 4, Earth and its Resources. As always, we start off with our key planning documents. I'm going to be referring to the pacing guide, the clarifier, where the vocabulary is, as well as components of the unit overview. So if you have those printed out, you can use those, or if you want to pause the video and open those up in a window behind this one, that would probably be helpful as well. All right, so Unit 4, in the 4th 6 weeks, we have 3 content standards, and each one of those standards is pretty involved and pretty complex. So we have organized those into 3 little mini units. So let's take a look at them. The first one is properties of soil. So this is 4.7a. This is a supporting standard. And the properties of soil you can see listed there on the screen. And you'll see that 2 of them I have in italics. And that's because those are the properties that in the past, based on data and teacher conversation, students have the most trouble really making connections with because they are pretty abstract. Color is very concrete, texture is very concrete, but the capacity to retain water, which is related to soil particle size, as well as the ability to support the growth of plants, those 2 things are a little bit more abstract. So you'll want to take more time to explore those 2 components of the properties of the soil, since that's a little bit more difficult for the students to grasp. The second of the 3 mini units is slow changes to the Earth's surface. Now, in 3rd grade, they looked at rapid changes to the Earth's surface. They looked at volcanoes, earthquakes, and landslides, which happen in a matter of minutes to days. In contrast, in 4th grade, we look at slow changes to the Earth's surface, which are caused by weathering, erosion, and deposition from wind, water, and ice. And these slow changes take millions of years. So again, another abstract concept, but also because it's on such a large time scale, particularly difficult for students to get without lots and lots of models and hands-on experiences for the students. This is not listed as a supporting standard per se by TEA, but we do list it as a key background for 5.7b, which is a readiness standard in 5th grade. And then finally, the last mini unit is looking at renewable and non-renewable resources. This will be the first introduction that your students will have to coal, oil, and natural gas, and then conservation is also linked with that. So we can talk about the new recycling program that's happening in the district, which makes that a nice real-world application. Next, I'll go ahead and put the 3 process skills up. These are usually integrated into the mini units through lessons in AIMS and STEM scopes, but I wanted to go ahead and show you these standalone here, specifically pointing out the use of tools to collect, record, and analyze information. And then another big process skill is going to be using models. And one of the big models that 4th graders will need to be using in this unit is going to be a stream table. And we'll talk a little bit more about what the stream table looks like, as well as how to set that up and how to use that. Okay, so we talked a little bit about the mini units. Let's take a look at the Earth and its resources as far as the unit overview. I always like to talk about the guiding questions, the approaches to classroom use, and the resources. So let's take a look at those a little bit more in depth. So on the unit overview, I've updated this from last year, and I've actually gone ahead and made the guiding questions correlate to the different content standards because each one is quite dense. And really by the end of the unit, your students should be able to answer these questions using the unit vocabulary. So I encourage you to use these questions as discussion pieces as you go through your units, maybe as an exit ticket, and then throw 1 or 2 of them onto your summative assessments at the very end of the unit, and ask your students to use the vocabulary that's up on your word wall or that's in their journals to answer those questions. And that's really going to help students take those abstract concepts and connect them to the vocabulary and apply them to new situations that maybe they haven't done in lab. So just a reminder that these can be used as assessments as well as discussion pieces. Um, with the process skills as well as the content, I've actually given you quite a bit of detail depending on what you might need. So this is from the page that has the approaches to classroom use, and you can see that I have a whole section on models right here, and you'll see a picture of that stream table if you're not familiar with that, and then really framing what your students should understand about models. I've also got a section here on conservation, and then I go into the content standards as well. So if you're new to fourth grade, or if you've been teaching fourth grade science for a while, it's great to look back on there and either say, oh, I haven't really thought about that, or yep, I'm doing all the things she's talked about, and that way you know you've pretty well hitting all of the major points that you need to have. Also, the resources section is going to have some specific lesson resources by the particular standard. Just to remind you that I've got some notes in here about some STEM Scopes pieces, and that's going to really designed to help you navigate through the resources and find the ones that are going to really be best fits for your students. The AIMS lessons that you see at the bottom of the screen are listed lessons that I would recommend. But do remember that when we talk about this particular standard with the property of soils, you're going to want to spend less time on color, and maybe this particular lesson could be good intros to it, and you're going to want to spend more time on these because it talks about retaining water and plant growth. Okay, so let's take a look at what's brand new to your fourth graders. They've never had this before, so you know maybe where you might need to linger a little bit longer in some of the units. So properties of soil is brand new. We really want to focus on having students notice that particle size is different in different types of soil, and it relates to water retention and the ability to support the growth of plants. So with that concept, just want to put two images up. Your students should experience a lab, and there's one in STEM Scopes and there's one in AIMS that looks like the one with the funnels and the beakers at the bottom. This is a very common way that this particular standard is addressed. You have different types of soils in the funnels, and you pour the same amount of water through each one of the funnels and through each one of the soils. But some of the soils are going to retain or keep water in the funnel more so than others. So that is a very common lab, one that they should do and analyze that data that they come up with. And so just from looking at this, you might want to even just kind of test yourself here and predict which one of these soils would be sand. Sand has very large particle sizes. And then which one would be clay? Clay having kind of on the end of the spectrum, very small particle size. So if it's retaining a lot of the water, that means that it's holding a lot of the water here. So not a lot of water is coming here. So this might be clay. But if it's not retaining the water, if it's letting it pass right through, like this one, you see most of the water that was poured in is now in here. This might be something with larger particles, so this might be the sand. So that's going to be a challenge for your students, and they'll get that the more concrete models they have of that. This is also a great time to go ahead and maybe start some seedlings from seeds, and try to plant some seeds in the different types of soils, and this can lead you into the life science, and you'll have some plants that have sprouted. Now, not all of the seeds will sprout in all of the soil samples, and that's okay, but some of them will, and probably in the potting soil. And so if you're in need of some seeds, you should have plenty left over from last year. You should have lima beans and radish seeds from last year, but if you're in need of some seeds, just shoot me an email and I'll be sure to get some of those to you. Okay, also brand new to your students is slow changes. Remember in third grade they had the rapid changes to the Earth's surface, and a mnemonic device that you can use to help students remember this is WED, like Wednesday, the weathering, erosion, and deposition. And a nice other way that you can remember what each one means, of course, your students are probably going to think weathering is like the weather. So this is a new word for them. So another way to kind of think about this is break it, take it, and drop it. So when you have a rock and it's weathered, it's broken. It can be broken by wind, it can be broken by ice, it can be broken by water. Take it is erosion, and that wind, water, and ice can actually take it away and move it to another place, and then deposit or drop it in another place. So again, you want to check out the approaches to classroom use in the unit overview for a little bit more detail, but that's a way that we found to be pretty successful to help students really understand what's happening. There's a nice little anchor chart in there as well. Okay, and then finally, non-renewable resources are brand new to your students. They've talked about renewable resources before, but this is the first time they've talked about coal, oil, and natural gas. There's another little anchor chart that you'll find in the unit overview that might help. So this is a lot of content with a lot of abstract concepts. So how do we tackle it all? I just want to really encourage you to pre-assess and then formatively assess as you move through your mini units. So let's take a look at some pre-assessment resources. As you know, STEMscopes has an assessment builder. It's up on the blue menu bar at the very top on the right that allows you to create a multi-format assessment. STEMscopes also has little 5-question pre-assessments as well as progress monitoring assessments, and some teachers don't find those to be quite rigorous enough, so I just want to encourage you to go back up to the assessment builder, and that way you can actually control the depth of knowledge and the type of questions that you might use. So pre-assessing your students, and then as you go through, formatively assess through exit tickets, or maybe just taking one of those pre-assessment questions that they maybe did very poorly on after you've gone through the lab and you've done a lesson or two on that. Give that question back to them and see, maybe in a different format or open-ended, and see how they do. Remember, those guiding questions in the unit overview would be great formative assessment resources also. I do have a strategy on here called Sticky Bar that has the step-by-step instructions on how to do that. This is a really great strategy to help your students once you've identified a concept that maybe they are a little fuzzy on, or they're not quite making the connection between maybe what you're doing in lab to maybe a multiple choice question. A sticky bar strategy is great. So let's take a look at what that might look like on the next slide. So let's say, for instance, your students are looking at properties of soil, and they're having a hard time understanding what retain means, or identifying which type of soil retains the least water. So you might have this question up on the screen, and you could have these written on the whiteboard, and you could have students come up and vote, or if you wanted them to do this more privately and more individually, you could have them write the answer choice on a sticky note, and then you build this bar graph. Alternatively, you could leave the answer choices off and leave this more open-ended, and then you could, as a class, cluster the types of answers that you have together. Regardless, it helps give the students as a whole as well as individually feedback, and starts to starting point for a discussion of why they're answering the way that they are. If you have a lot of I don't knows, obviously we need to go back and maybe point out, maybe in the lab, the component of it that'll help them make that connection and so forth. So as we wrap up, I just want to remind you about the vocabulary. For all 3 of these content standards, you're going to want to go to the clarifier. Under academic vocabulary, I have all of the terms that come directly from the standard, as well as related terms. And these are words that we found either show up on STAR, or they really are words that students maybe have not encountered before, but they are really critical in order for them to understand the standard and understand what that concept means. You can find a list in STEMscopes as well, but remember, that is not all of the terms on the clarifier. So you'll want to use the clarifier as the master list if you're using STEMscopes as a resource as well. So I also want to just remind you about how to use some of these vocabulary terms in an interactive word wall. These are some examples from Dr. Julie Jackson's Facebook page called Science Toolkit, and these are some that I pulled from the Facebook page that go along with the standards that are in the unit. Not saying these are the perfect ones or ones that you should necessarily replicate, but they're just some ideas that teachers have sent in as some things that they've done So if you have started in on the interactive word wall, you might want to go ahead and take it to the next level by visiting the just-in-time learning back in Canvas. Dr. Jackson has just published a brand new article called Claims and Evidence. It's brand new this last December in Science and Children, and it really takes the word walls to the next level to having your students make a claim using evidence from your word wall. So again, you'll be able to find that back in Canvas. If you weren't able to start an interactive word wall yet and you want a refresher of how to get started, back in Canvas in the third 6 weeks, I have a 16-minute interactive word wall overview in a starting guide. So it takes you step by step how to get started on an interactive word wall, as well as gives you a link to Dr. Jackson's website as well. And so if you, again, didn't get a chance to attend Dr. Jackson, or if you haven't gotten started yet, I would encourage you to go back to the third 6 weeks to the just-in-time learning. And then finally, as we finish up, I just want to remind you about some useful equipment for this unit, as well as talk about the stream table. Just arrived on your campus are some new nesting soil sorting sieves, and those are pictured up here. There are different screen sizes so your students can sort by particle size. We also have some tray sieves that are in the lab as well, but these are some new resources that we have. We also have the Smart Scope. There's a great engaged lesson in 4.7a where students make a little soil slide with tape and soil, and then you could use the Smart Scope to take a close-up look at that. Stream tables, we mentioned those before. Here's the picture from the unit overview on that. If you're not familiar with stream tables, exactly how to use them, or you would like to see some visuals of how to set those up and how that works, in Forethought, underneath the process skill that lists the stream table, which is 4.3c, there's actually a little PowerPoint right here under the related resources for you. So I just want to make you aware that that was in there. And then we also have different types of soil, and those are located in the yellow canisters that are in the science lab. So thank you so much for joining me. I hope that this has been helpful for you as you get ready to plan for the 4-6 weeks. And as always, please reach out if I can help support your science program in any way. Thanks so much and have a great day.